My name is FATHIAH Binti Badrudin. Magic number is B0819103220. I will start presenting on IoT early flight detection and avoidance system. The proper system will use Arduino as a microcontroller and be connected to Wi-Fi in order to send sensor data to the user's smartphone via an application. The application will display data from the ultrasonic sensor, humidity sensor, and temperature sensor. The main objective of this project is to forecast flooding by monitoring the water level at certain locations and using an alarm system in both applications and real life. Difficulties and problems. During the execution and development of the mini project, we are confronted with a number of problems and obstacles. Firstly is insufficient ultrasonic sensor power. We cannot observe any reading from the ultrasonic sensor during simulation. After conducting A/B tests to determine the source of the problem, it is shown that the ultrasonic sensor lacks sufficient power to function properly. Second is application reading configurations. During the simulation, we observed that the display reading differs from what we had anticipated. Initially, the reading indicated a lower percentage of water level. However, the condition has been determined to be dangerous. We are able to resolve the issue after modifying the single line of code within the Arduino IDE. Thirdly, in simulation, we find that it's difficult to precisely adjust the sensor distance from the water level. To fine-tune the distance, we must configure the maximum distance in the Arduino. Additionally, to properly test the simulation, we are required to proper equipment such as clear glass aquarium to observe the gradual rise of the water level. Lastly, group members meeting. As the end of the semester approaches, every member of the group is preoccupied with their own plans. Therefore, it is difficult to find an appropriate time to meet and discuss the project. The issue is resolved by having an online meeting where they can share their progress and problems with other team members so that they can be assisted and the issue can be resolved, so that the problem does not impede the progress of each group member in completing the project. We typically meet at least twice a week.
Assalamualaikum and hello everyone. My name is NAJWA binti MOHAMAD HAFIZ from BEEE. So in our project, which is the IoT early flood detection and avoidance, this system will be implemented with both hardware and also software. So this is the hardware design that we have created by using Proteus. The circuit diagram consists components that we use in our project. So this is the list of the components that we are going to use in our project, which is the first one is Node MCU, LUA V3 ESP 8266 Wi-Fi with CH340C. So the function of the Node MCU is to it is a low-cost open-source IoT platform. It initially included firmware which run on the ESP Wi-Fi from Express system, and hardware which was based on the ESP12 module. So this microcontroller with integrated Wi-Fi can perform for IoT connection. The second one is the 5V DC HCSR04 ultrasonic. This ultrasonic sensor uses sonar to determine the distance of an object. It is offered excellent non-contact range detection with high accuracy and also stable readings. Next is the 3 to 5V piezo buzzer with wires. So the piezo buzzer are simple device that can generate basic beeps and also tones. They work by using a piezo crystal, a special material that change shape when voltage is applied to it. And then we have DHT to temperature and humidity sensor. This sensor use a capacitive humidity sensor and a thermistor to measure the surrounding air and spit out a digital signal on the data pin. And then the last one is the potentiometer. So the potentiometer acts as a variable to show the level of the water. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAIKAL and ARIFFIN. I will proceed to hardware connection. This is our schematic circuit, which is the first our water simulation for the first circuit. We can see here the main controller is here Arduino Uno as our controller. And then the water level, here we use variable resistor, and then this is ultrasonic sensor, which is to detect water level, and that is temperature and humidity sensor, the STH11 to detect temperature and humidity, and this is LCD display to display all data get from Arduino, and this is a Wi-Fi module as our Wi-Fi connection. First we see the ultrasonic sensor connect with Arduino Uno 5 VDC. We will operate the sensor, ultrasonic sensor, and ground, and then triggered the ECNO is for important to detect the certain level of obstacle, and the ECNO is very important to receive back the signal. And then we can see the connection to Arduino Uno. Ultrasonic sense certain level like first level, second level, third level from the water level. So this is our implementation circuit, that means our real circuit, which is we can see here we replace Arduino Uno microcontroller with the MCU V3, which is the different between Arduino Uno and the MCU. Here is Arduino Uno must be added with Wi-Fi module to connect to IoT or Wi-Fi connection, but the difference is with the MCU is the MCU microcontroller is already integrated Wi-Fi module in this board, so we no need to add additional Wi-Fi module. So the connection is same with microcontroller, MCU with ultrasonic sensor and our temperature humidity. When the operation is also same. When certain level or certain situation, the ultrasonic will detect water level, and then we send the signal to MCU, and then the MCU will be send the data to our application Android. And also same here, humidity sensor, the HT11, temperature and humidity will be sensed by microcontroller, the MCU, and then sent to application. So this is our simple board circuit, which is connection between microcontroller and MCU, ultrasonic sensor, and the ST11 temperature and humidity. That's all for me. Thank you.
Hi, Assalamualaikum and greeting. Now I will present for Android Studio, the layout and the Java code. Here is our first layout, which is our login page. To login, the user must enter their username and password, and we originally made the username and password for this login page inside main.activity.java. I'll show here. Our username is group3 with number, and our password is group3 in spelling. So basically, a function toast will appear with the message login failed, as shown here. So I will show in our apps. When the username or password is incorrect, it will toast login failed. So if it's correct, which is our username is group3 and password is group3 in spelling, and it will take us to our second page, which is our dashboard page. On this page, we have our project title, which is Smart IoT Float Monitoring System. Inside this layout, we present three values from our input sensor. First is our ultrasonic sensor that measure water level, and our second sensor is the HT11 sensor that measures temperature and humidity. For the condition, it will be explained in the Arduino IDE section. Now, I will demonstrate whether our Android Studio is linked to our Firebase. So we have here a DHT and a water level reading. I see here HT reading and water level. As a result, when we update the value in Firebase, it will interact with our apps. I will show. You can change the value from 30 other integer value. Let's say 50. So humidity will change for the temperature 37 temperature, and also the ultrasonic sensor, which is the water level 100. To change it out automatically, we need to connect with the hardware. When the situation changes to warning, the user can use the emergency call button up right here. Can click here. So we have 3 phone numbers on our emergency page. The first number is an emergency number, while the other two are social welfare department number. By clicking on the phone number, it will be taken directly to our phone call. So basically, this page was created to allow user to make emergency call easily. Furthermore, when user not use this app, they can log out in the up left inside our dashboard page. That's all for our GUI.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is AMIR FADZLI, and right now we're presenting for software part, which is Arduino IDE code. Okay, I will present roughly for this code. For this one, we will include a DHTH where it is for DHT file header, because in this project we use DHT to measure the temperature and also humidity. And so for the both of this is for the connection between ESP8266 and also the Firebase. And so this here is 3 line. This is to define the pin for hardware, and then this is for the type of DHT we use for this project. And also for this one, it will show the link and also the authentication for our Firebase, and also the Wi-Fi that we use to connect with the Firebase. Okay, as you can see, the path that we use is water level. So as you can see here, this is the water level calculation, where the calculation, the value that we will show in the database is in percent. So if the value is below than 10, it will display safe. If the value is below than 60, it will display please beware. And if above than 60, it will display warning for water level. Also for this one is for humidity and also temperature. The path that will write below it is DHT reading. And also if the DHT is cannot receive any data, it will display fail, either temperature or also humidity. Okay, if you run this one, it will automatically display at the Firebase. So it will show the DHT reading, humidity, temperature, and also water level, condition level, and also the percentage. This here is the water level of the water. Okay, that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Ashraf bin SALMI. Matric number is B0181910067. So today I will be explaining about the output or the simulation of our project. So this is the animation. The blue box here is the ultrasonic sensor, and this is the enclosure that all the ESP and stuff will going to be stored. And this green box here is the river that it will going to be put. So as you can see here, this sensor will show two things, which is the water level and the condition. So if we play, so if the water level past 10%, it's going to change the condition from safe to warning. And then if we play above, if the water level above 60%, it's going to be danger. So as you can see here, this is warning. Up to 60, it's going to be danger. So that is the simulation for our project. This is the prototype output of our project. That's all from us. Thank you.